Welcome student 0. Today's online section of subject Industrial Hydraulics and Pneumatics. Today we are going to see the hydraulic pump and some of its various types. Okay, so here we are. So what is this pump? The pump, it is the heart of hydraulic system and converts mechanical energy into the hydraulic energy. You see there is a pump in every hydraulic circuit. It is the heart, it is like heart of this hydraulic system which pumps the fluid. This main purpose of pump is to create the flow of oil through the system, thus assist transfer of power and motion. The combination of pump and driving electric motor is known as hydraulic pump. This pump is always association with the motor. Actually this pump is run by the motor. The hydraulic pump takes hydraulic fluid from the reservoir and delivers it to the rest of the hydraulic circuit. In general, the speed of pump is constant and the pump delivers an equivalent volume of oil in each revolution. Actually, in each stroke or in each revolution. Here we are going to say this hydraulic pump are characterized by its flow rate, capacity, flow consumption, drive speed and the pressure delivered at the outlet and efficiency of the pump. The pump are not actually 100% efficient. The efficiency of pump can be specified by the two ways. One is volumetric efficiency and another is the power efficiency. The typical volumetric efficiency of pump varies from 90 to 98%. Then here we are to see this classification of hydraulic pumps. These pumps are classified into two: positive displacement pump and non-positive displacement pump. This positive displacement pump have the fixed discharge and this non-positive displacement pump have the various discharge. This positive displacement pump, in this, from entry to exit, the liquid is in contact with the stroke or with the component, but in non-positive displacement not such happens. I will show you this difference between the two in brief in the next slide. Here we are going to see this for positive displacement pump. The displacement is positive, means irrespective of the increase in pressure the pump discharge remains constant, but in case of this non-positive displacement pump the discharge varies as the pressure varies. As a hydraulic system has to develop large amount of forces, only positive displacement pump can be delivered discharge under high pressure. It is again having two types: rotary pump and reciprocating pump. Here in case of non-positive displacement pump, here the discharge does not remain constant. With increase in pressure, discharge is reduces. Here pressure means the back pressure, and oil cannot be delivered by pump at high pressure. Here this positive displacement pump can pump oil at high pressure, at high back pressure. So we may say that this positive displacement pump can be delivered the high pressure. The moving component carries the liquid, the moving component moves and liquid has to be moved with it. But in case of this non-positive displacement pump, the high speed moving component give off its kinetic energy to the liquid, and with this kinetic energy the liquid moves from inlet to outlet. Now normally we prefer reciprocating pump over the rotary pump. This is because this reciprocating pump can produce the high pressure and it has reasons for not using the reciprocating. Here the reasons for not using reciprocating pump is listed, because reciprocating pump has more number of moving components such as piston, crank, connecting rod, etc. The familiar example of this reciprocating pump is the air filled pump which we are using to fill the air in the cycle. सायकल भरामध्ये हवा भरायचा जो पंप आहे तो कुठला टाइप आहे आपला? रेसिप्रोकेटिंग पंप. ड्यू टू विच कॉस्ट and size and maintenance is poor. Also strong foundation required to sustain the vibration. The fluctuating load and flywheel is required here in case of the reciprocating pump. Overall size of plant increases and machine becomes bulky. Then here are some advantages or reasons for preferring rotary pumps. The rate of flow is remains constant. No fluctuation load or no need of flywheel. Discharge is smooth here and it has very less vibration and noises. Due to lesser part, pumps are very compact, means small in size. Cost is comparatively low here. Its maintenance is easy. Here the difference between the positive displacement pump and non-positive displacement pump is mentioned. In positive displacement pump, the moving component carries the liquid along with it and it from inlet port to the outlet port. But where in case of this non-positive displacement pump, the moving component gives off its energy to the liquid. Due to this, the liquid will drawn from inlet port to the outlet port. Here in positive displacement pump, discharge remains constant, but here in case of non-positive displacement pump, discharge is not remains constant and it depends on the pressure. Here for the positive displacement pump, less discharge but more pressure. Here more discharge with less pressure in case of non-positive displacement pump. Here in positive displacement pump, the delivery valve should not be closed while the pump is running, but in non-positive displacement pump, the delivery valve should be opened slowly only after maximum pressure is reached. Here are again the classification of this rotary pump. They are classified as gear pump, then vane pump, then piston pump. The gear pump are further classified as external gear pump, internal gear pump, lobe pump, gear rotor pump. Here we are going to see its okay, so this is the diagram on your screen which is of external gear pump. What are the main components? Is having a two gears. One is the driver, another one is the driven. Driver is connected to the motor and driven is gets run along with by the motion of this driver. One having inlet port and one having the outlet port. Due to the constant rotation of the gears, it causes to suck inside the fluid and produces and push it outside to the outlet. Here when the driver is rotated by means of the prime mover or by means of the rotor, driven will also rotated. The partial vacuum is created at the inlet of the pump. Oil is forced to enter to the pump by atmospheric pressure and oil is trapped in the pocket between the teeth casing and carries toward the outlet port. Here we are going I am going to show you some animations. This is the external, this is the driver gear which is connected with the motor, and this is driver gear. And the next one is the driven gear. Initially this oil is get trapped between this gear there. Initially vacuum is need to be produces and oil is get suck at atmospheric pressure and it push outside in the outlet at high pressure. This is the working of external gear pump. You can see the outlet port, and outlet port the pressure is high. Now we will see internal gear pump. This is the Working of internal gear pump. Internal gear pump having inlet and outlet. This is the connected with the prime mover or motor. Here again both inner gear and one is the external gear. This is internal gear pump. This is the driver and outer one is the driven one. Here the liquid is get trapped between the two gears, and at the outlet at very high speed, high pressure fluid is get obtained there. Here this is internal gear pump. So external gear and internal gear is connected to the prime mover there. Okay. The external gear is inside the internal gear. The two gears are in mesh with each other. The second seal is provided between the two gears, which fills the gap between the two gears. As the teeth of the gear comes out of the mesh, a partial vacuum is created, and hence oil filled in the pocket between the gear teeth and the crescent seals trapped there. Here you can see the crescent seal, and in this crescent seal the liquid is get trapped there, and high pressure oil is obtained there. Okay. Now the next type is the lobe pump. Here instead in place of gear only the lobe are used, else the remaining working is same. Now this is this generated rotor pump. Here this pump has two generated rotor. One is having external teeth and another having the internal teeth. The rotor with the external teeth rotates inside the rotor having the internal teeth. The inner rotor is having one tooth less than the outer rotor. Okay. The size of all pocket goes on increasing as the rotor rotates, thus form more oil fill in the pocket. After 180 of the rotation, further rotation causes the size of the pocket to reduce, causing the oil to flow out of the pocket. Thus from each pocket oil is sucked in from inlet port during the first half of rotation, and oil is delivered to outlet port during the next half. There are 6 such pockets. 3 of them are performing suction while the remaining 3 are delivering the oil. And this is the working of this generated rotor pump. I will show you the screw pump in the next section.